Hi everyone, today's video is a big data cleaning project using Python. We will be replacing some values, splitting columns, and then creating various visuals, including Wordcloud. I will also show you how to create quick data profiling report to analyze your data. If you're new to this channel, I'm Karina. I have transformed my career from finance to data, and now I help others to do the same one step at a time. Let's dig in. I was at Kaggle.com looking for some dataset for data analytics project, and I came across the file. It's called Data Scientist Job Roles in UK. I assume someone scraped all this data. The folder actually has two files, cleaned and raw data, but I think we should work with raw data and clean it ourselves so we can practice the skills. As always, the first step, we need to import Pandas SPD because I will be using Pandas module to read our file. Next step, we will read our file. We will create a new data frame called df. So df equals pd.read_csv brackets, and then in the brackets we indicate the path to our file, and as you can see I will be reading the file that's called raw dataset. To see top 5 rows of your dataset, you need to say df.head brackets. That's how our dataset looks like. We have company, job title, location, a salary, and skills. As you can see, salary has this pound sign and also some details in the brackets. We also have salary ranges, so minimum salary and maximum salary. So we will work with that too. And I also think it is a great project that you can use and analyze in Excel, also practicing how to clean this dataset in Excel. To see statistics about your data, you can use .describe. So let's do that. We say name of the data frame or df.describe brackets, and we say include equals all to get details for all the columns in our data frame. So looks like we have 750 rows in our data. If you want to quickly create a summary report for your data, you can use something called a profile report. First of all, you need to install these modules into your environment. So you need to say !pip install ydata profiling, because we will be using this module to create the summary report. And you also need to install ipywidgets. Run these 2 lines of code, install those modules, and now from ydata profiling we will import profile report. Now say profile equals profile report brackets. In the brackets we indicate name of our data frame, in our case it is df, comma, then you can give a title to your summary report. I will just say it summary report, and then to display it we say profile.to_notebook_iframe brackets. Let's run it, and it created a great summary report that has all the stats. For example, we know how many number of variables, how many observations, so 750 rows. We know how many missing values we have in our data. It also has Wordcloud, and you can select variables for your Wordcloud. For example, if you create it for skills, you can do this for job title, for example. It also creates a correlation matrix, which is as a heat map or table, and it also displays first and last rows of our dataset. So this summary report is great as a quick way to check how your data looks like. Of course, you can use more traditional ways with .describe, .info, etc. But it's good to know that there are other options too. We can see that our salary column requires a lot of work. So again, we have this pound sign. Instead of thousands, we have a K, so we need to replace that with 3 zeros. Also, we don't need employee estimate or Glassdoor estimate in brackets. We need to split ranges into minimum and maximum, and we also have per hour rate, which we will convert into yearly salary. First step, I will replace pound sign with nothing, and I will replace K with 3 zeros or 1000. Once we've done the cleaning, we need to assign this data back to our column, and because of that we say name of our data frame square brackets column name of salary equals, here we indicate what we are changing. We are changing our salary column, so df square brackets salary dot string dot replace, and here we say what we are doing. So we will replace pound sign with nothing. If you use in Excel, it is find replace or Ctrl+H, where you say what you find or pound sign and what to replace it with or replace with nothing. Then we say again .string.replace. In this case, we're replacing our K with 3 zeros. And I will keep printing df head so we can see how our column changes. Okay, now we can see that there are no K anymore and no pound sign. Now let's replace also employer estimate and Glassdoor estimate. Similarly, we say df square bracket salary equals name of the column, or df square bracket salary dot string dot replace. So we're saying what to find, or find this brackets employer estimate and replace it with nothing. And same with Glassdoor. Let's run it and let's rerun df head. You can see, so now those things are also gone. The next step, we need to replace our hourly salary to a yearly salary. So we assume that there are 40 work hours in a week and we have 52 work weeks in a year. So it will be 2080 hours. Basically what we will do, we will look for per hour in a column salary, and in case we have found this per hour, we will extract the number and then we will use that number to convert it to yearly salary. For that, we will use regular expression or var module, so we can find all this data. We need to import our var module, so we say import var, and now we will create a function that then we will apply to our salary column. To create a function in Python, we always need to define it, and then we need to return the result of the function. We say def to define the function, then we indicate the name of our function. I say convert to yearly, brackets, in the brackets I say what we convert in our salary, colon. If per hour in string salary, then we extract hourly rate, and to extract it we say hourly rate equals var or regular expression find all, and what we find digits before the dot, and it can have or not have digits after the dot, and we're looking for it in salary. So what happens here, so we found this hourly rate, we extracted it, then we multiplied it by 2080 to convert to yearly salary, and then we also convert it to float, and then we return that. And to apply our function, we say df square bracket salary, name of our column, then we say where we applying our function to. We applying it to, again, df square brackets salary dot apply brackets, in the brackets a name of our function. So let's run it, and if we rerun our df head, you can see that our hourly salary was converted to yearly salary. As a next step, we will split those salary ranges into minimum salary and a maximum salary. To do that, we will use string.split, but we need to make sure that all the values in this column are strings. So we say df square bracket salary dot s type string. So we make sure that all the values in this column are strings. Now we will create two new columns, salary min and salary max, which will be splitting of the salary column we have at the moment. Df square brackets for a column, but this time we're creating two columns, so then we need to create a list of those columns. That's why we have two square brackets in this case. So we say salary min comma salary max equals df salary. We need to indicate the column which we will use for our manipulation, dot string dot split brackets. So we're splitting by hyphen, and then we say expand true. Let's run it, and let's run df head brackets. This is how our data looks like. So now we have two new columns, salary min and salary max. Once we've done our split, we splitted our data based on a hyphen, but you can see that before the hyphen and after the hyphen there was a space. And it is white spaces which can cause some issues when you try to visualize your data, or when you're trying to convert it to number. That's why the next step, we need to strip our values. We need to remove all those white spaces. To remove spaces, we will use dot strip. At first we say name of the column, df salary minimum equals df salary min dot string dot strip brackets, and the same for salary max. Now let's convert values in these two columns to numeric. So we say name of the column equals pandas or pd dot to underscore numeric brackets, then name of the column, and then comma error squares. Why we adding this? Because our columns have some non-values, and if you don't do this, it will cause an issue once you're trying to convert data to numeric. The next step, we can also split our location data into city and countries. Again, before we split it, we need to make sure that our data is in a string format. That's why we say df square brackets location equals df square brackets location dot s type string. So similar what we've done to salary column before, we will do the same to our location to make sure it is a string. And now we will split the location into two new columns, again similar to what we've done with salary, to split it into minimum and maximum salary. So df square brackets, another square brackets for a list, city, country equals df square brackets location dot string dot split brackets in the brackets comma, because we are splitting by comma, and equals 1, expand equals true. Let's run it, and if we rerun it, now we have two new columns, which is a city and country. And the only column we haven't touched yet is skills. In the skills column we have a list of all the skills required for this job. In Python we can apply one-hot encoding. So what will happen? Python will create columns for each possible skill in this skills column, and then for each of them we will have a binary result 0, 1, so yes or no. So we say skills split equals df square brackets skills, so we use our column skills dot string dot get dummies, since they all have comma between them, so we say separator is comma. Let's run it. If we run our skill split now, that's what we can see. So it created all possible new columns from AI to iOS development, and all the data should have 0 and 1s. So for each job we will know if it's yes, it is 1, if it's no, it's 0. So, and now we can combine it with our original data frame. You can either merge it or concatenate and create a new data frame that combines two of those data frames. So df underscore with underscore skills equals pd dot concat, and then in brackets I say what I'm concatenating, what I'm combining. I'm combining the original data frame and the skill split. Axis equals a 1, and we want to print ahead of this so we can see what happened. You can see this new data frame has all the columns that we added, like a city, location, salary, minimum and maximum, as well as all the skills. So now we are done with all the cleaning and we can visualize some data. So first one, we will create a word cloud. I have a separate video where I talk how to create word cloud. From word cloud you need to import word cloud. We will visualize all the skills, so we will sum the data, because in each column we have 0 and 1s. So if it's 1, it means that the skill exists. So we will create this new variable called skill frequencies, which is df with skills. iLocation helps us to identify location of the columns. When you use iLocation, first part is rows and the second part is column. So what I'm saying, I want find me all the rows, that's why I use this colon, comma, and which columns I want from there. I want all the columns starting from AI, because that was the very first skill we had, up to the end. If you want to say up to the end, you just use colon, and I want to sum them. Let's print our skill frequencies and look at the data. So now you can see that 54 jobs ask for AI, 19 jobs ask for API, etc. So that's the data we will be using to create our word cloud. To create word cloud, we say word cloud equals word cloud module brackets, and then we need to select width and height of our data, which will be in my case 800 by 400. Background color equals white, because by default it is black and it is harder to read, so I prefer to always switch it to white. And then we say dot generate from frequencies, because we created frequencies before that. So generate from frequencies brackets skill frequencies. And to display our word cloud, we say plt.show brackets word cloud interpolation by linear. We will need to switch off axis, that's why we say plt.axis off, and plt.title to add title to our word cloud, and we say plt.show to display the word cloud. Let's run it. And that's how our word cloud looks like. So we can see that machine learning, Python, TensorFlow, SQL, definitely the words that stand out from this dataset. Now let's create a horizontal bar chart to display top 10 skills required. We will create a new variable called skills columns, which will be similar to our frequencies. We will say df underscore with skills, iLocation, and again we're selecting all the rows and we're selecting columns from AI to the end, so all the columns that contain our skills. We say dot sum, sort values, and we say ascending false. So we sort all our values in descending order because we want to select top 10 skills. So let's run it. Now to extract top 10 skills, we will use .head. We usually use .head to review rows in our data frame, but you can also use it to select those rows and assign it to new variables, and then you can use it to, for example, visualize it on a graph. We say top_10_skills equals skills columns, the variable we've just created, .head 10. So this way we select top 10 skills. And now let's plot the results. Any visual, we start with selecting the figure size, so we say plt.figure and then brackets figure size 10:6. Then we are plotting our data, so we say top_10 skills dot plot, and then in the brackets we need to indicate the type of the chart we're selecting. We're selecting horizontal bar graph, that's why we say bar H, and the color will be green. And then we need to select the title, Y label, X label. We will add plt.gca brackets dot invert y-axis brackets. This will help us to display most popular skills at the top. So it's like a sorting our bar chart, and plt.show to display our bar chart. And now you can see the skills. So the most popular is machine learning, then we have SQL, TensorFlow, R from the data we have. For example, you want to make a similar bar chart, but you want to display only the skills required for a specific job. So you want to filter job title and then display the skills for that job. Let's do that for data analyst. So at first we are filtering our data. We will create a new data set. We'll call it da_jobs equals name of the previous data frame which we are filtering, or df with skills. So you say df_ with skills square brackets df with skills dot string dot contains, and then in the brackets we are filtering for data analyst, and then case false and a false. There are other options how to filter data, but this time I decided to show you this one with contains. Similarly to above, we need to sum values and sort them in descending order. So how we created skills columns here, we will do the same for our new data set. So we say da_skills and then da_jobs, which we've just created, I allocation, and again all rows, all the columns from AI to the end, dot sum to sum the values, dot sort values, ascending false. And just as above, we will create a new variable top 10 skills, and then we will create our horizontal bar chart. So da skills.head 10 to creating this variable, and then to visualize it, plt.figure to select size, .plot kind bar H, exactly as we've done above. This is top 10 skills for job titles data analysts. Another visual I want to create today is a salary distribution. To create a salary distribution, we will create a histogram. So again, as always, we start with selecting figure size, which is 10:6. To create histogram, we say plt.hist brackets, then you select the columns you want. I want minimum and maximum salary. Bins will be 30. Our labels will be minimum and maximum salary. Color will be blue and green, so blue for minimum salary, green for maximum. Alpha 0.7, it is transparency. plt.title, and then we add our title, X label, Y label. I want legend, so I know which one is minimum and maximum salary. plt.grid true, I want some grid lines on my visual, and plt.show to display our histogram. And that's the result. So now we can see the distribution of our salaries. If you want to visualize top 10 companies and top most common job titles, we can create two new variables, one for top companies, one for top job titles. So top companies equals df square brackets company, name of the column, dot value count brackets, dot head 10, so to select top 10 most common companies, and similarly for top job titles, and we can visualize those two things as well. If we visualize our top 10 companies similar to what we've done above, but this time we will create just bar chart instead of horizontal bar chart, just normal bar chart, and color sky blue, title, labels. So on the data we have, JP Morgan was the most common company, and let's visualize top 10 job titles. Similarly to bar chart above, we just this time we visualize top job titles. Okay, so in our data, the most common job title was data scientist, then we have senior data scientist, ML. You can see we have data scientist, capital D, capital S, and we have data scientist that all the letters are capital. In that case, we can replace this data scientist to align with this, so the data is combined. To do that, we say df square brackets job title, because we need to assign it back to the original column. Then we say name of the column, or df job title, where we replace in our data. Similarly, what we've done to salaries, we say dot string dot replace, and what we replace in this data scientist, we replacing with this data scientist, case equals false. If now we rerun this graph, let's do quickly. So we will rerun this variable, and then we will rerun generation of the graph, and now you can see that there is no more data scientist all capital letters anymore. That's it for today. I hope you found this video useful. Please let me know in the comments below, and I hope to see you next time.